Hello everyone, and a very warm welcome back. It's great to have you here. I'm Sam. In our previous sessions, we've been the architects of what if. We've explored how to build a business case and align solutions to strategic goals. Today, we become the engineers of how. We get practical and ground our ideas in reality. Our focus is K15, principles of estimating cost and time resource constraints within digital and technology solutions activities. Our purpose is to give you the confidence to answer the three big questions that every manager, client, and stakeholder will ask before any project can begin. How much will it cost? How long will it take? And what, and who, do you need to get it done? By the end of this session, my objective is for you to understand these principles so well that you can apply them to your own work, build credible plans, and, crucially, know exactly how to create powerful evidence for both your portfolio and your final major project. This isn't just a nice to have. This skill is the foundation of professional trust. It's what turns a brilliant concept into a successful, real-world project. So let's get into it. First, let's get our definitions right, because the words in K15 are very precise. The most important one is estimating. I need you to separate this word from knowing or promising. An estimate is not a guarantee carved in stone. It is a forecast. It's an educated, data-driven approximation based on the information you have at that exact moment. Like a weather forecast, its accuracy depends on how much data you have and how far into the future you're looking. The forecast for tomorrow is very accurate. The forecast for this day next month is an educated guess at best. Our projects are the same. Next, cost. This is the total financial spend. It's not just the salaries of the development team. It includes every software license, every piece of hardware, the monthly bill from AWS or Azure, and the cost of any specialist contractors. Then there's time. This one seems simple. It's the calendar duration. How many weeks or months from the day we start to the day we deliver? This is what allows the rest of the business to plan. Finally, resource constraints. This is the who and what you need, and it's the most important constraint. It's the limit on your people and their specific skills, the software, and the equipment. A constraint, like, we only have one senior data analyst, is usually the primary driver that dictates the final cost and timeline. Now, I'm going to share the single most important principle in all of project estimation. If you remember one thing from today, make it this. It's called the cone of uncertainty. The cone of uncertainty is a simple but profound idea. It states that at the very beginning of a project, when you have the least amount of information, your estimates will be wildly inaccurate. The potential range of what the final cost and time could be is enormous. This is the wide, open end of the cone. But as you move through the project, you learn more. You gather the requirements. You create a detailed design. You build a prototype. With every unknown that you make known, you reduce uncertainty. As uncertainty decreases, the accuracy of your estimate increases, and the cone gets narrower. The perfect analogy is a hurricane forecast. When a storm is 5 days out at sea, the forecasters show a huge cone of its potential path. They are being honest about the uncertainty. By the time it's 1 day away, they have much more data, and the forecast path is very precise. Your job isn't to fight the cone, that's impossible. Your job is to communicate it, and to do the work that moves you down the cone to a place of certainty. So, how do we actually go about creating these estimates? There are dozens of specific techniques, but they generally fall into two big families, top-down and bottom-up. Top-down, or analogous, estimation is when you start with the big picture. You look at the whole project and make a high-level guess, usually by comparing it to something you've done before. You might say, the last time we built a mobile app like this, it cost £80,000 and took 4 months. This new one feels about the same size. So let's budget for that. It's very fast, which is why managers like it for an initial, ballpark, idea, but it's often very inaccurate because the details are hidden. The more professional and reliable approach is bottom-up estimation. This is the opposite. You start by breaking the entire project down into the smallest possible tasks, creating what's called a work breakdown structure, or WBS. You estimate the time and cost for every single one of those tiny tasks. Build login page, 3 days, configure firewall, 1 day. Then, you add all those small estimates together to get a total for the whole project. This method takes a lot more work, but it is always far more accurate because it forces you to think through every single detail. So, how can we get really good at estimating those individual tasks in our bottom-up plan? A very powerful principle is to stop trying to find one single, perfect number. Instead, we embrace uncertainty by using three-point estimation. Instead of asking a developer, how long will this task take, you ask them for 3 numbers. First, the optimistic estimate, O, the best-case scenario, if everything goes perfectly with no interruptions. Second, the most likely estimate, M, the realistic guess, assuming the normal amount of daily friction. And third, the pessimistic estimate, P, the worst case scenario, if the technology fights you and the requirements are unclear. Now you have a range. You could just take a simple average of the three. But the professional, and statistically better, method is to use the PERT formula. You take the optimistic, add 4 times the most likely, add the pessimistic, and then divide the whole lot by 6. This weighted average is far more robust because it gives more importance to the most likely number while still factoring in the risk from the pessimistic estimate. It's a simple, brilliant tool for creating a defensible estimate. Now, many of you, especially our software engineers, might be thinking, my team doesn't talk about hours or PERT formulas. We use story points. That's fantastic. That is just a more modern, often faster, way of applying these very same principles. Many Agile teams use relative estimation. They found that estimating in time is very difficult. It's much easier and faster for a team to look at 2 tasks and agree that task A is relatively twice as much work as task B. That's where story points come in. A story point is an abstract number that combines not just the effort, work, but also the complexity, brain power, and the uncertainty, risk. A 5-point story is roughly bigger than a 3-point story. You'll see this done with techniques like t-shirt sizing, XS, S, M, L, to get a quick feel for large items, especially early in a project. Or you'll use planning poker, where the whole team uses cards to vote on the story points. This forces a discussion and leverages the entire team's expertise to move down that cone of uncertainty together. This is a core KSB, so let's make it real for each of your pathways. The principle is the same, but the application is different. For you, Chloe, as our software engineer, you will live this in your Agile team. When you're in a sprint planning meeting and you play planning poker to estimate a user story, you are applying K15. Your 5 or 8-point estimate is a professional forecast of the effort, complexity, and uncertainty of that task. For Ben, our data analyst, your manager will ask, how long until I can see that analysis? A junior analyst guesses. A professional analyst, like you, uses a bottom-up approach. You'll say, it will take 1 day to get and clean the data, and then 1 day for the analysis and visualization. I can have it for you in 2 days. You estimate the stages. And for Liam, our network engineer, your role is a classic, perfect example of bottom-up estimation. You'll be asked to plan an office network upgrade. You will create a detailed plan listing the cost of every single switch, router, and cable, and the labor time in hours required to install and configure each one. Continuing with our other pathways. Aisha, as our IT consultant, you are the master of this. You'll use different techniques at different times. You might use a top-down, analogous estimate to give a client a quick, ballpark cost in an early meeting. But then, your main job is to lead the whole team to create a highly detailed, bottom-up estimate that will become the formal, legally binding statement of work. Tom, as our business analyst, you are the enabler of good estimation. You are the one who defines the scope by writing clear requirements. Without your work, a bottom-up estimate is impossible. You also need to estimate your own work. How long will the analysis phase take? You'll estimate the time for workshops, interviews, and documentation. And Maya, our cybersecurity analyst, your work has a unique twist. You'll do standard estimates for the time of an audit or the cost of a new firewall. But your most powerful use of K15 is estimating the cost of an action. You'll build a business case by saying, this new security tool will cost £20,000, but the potential cost of a single data breach that it prevents is estimated to be £2 million. You are estimating risk. Okay, let's get this into your portfolio. K15 is assessed in your professional discussion, which is underpinned by your portfolio. This means you need talking points, clear, simple stories of when you applied this knowledge. Here are 3 easy, high-impact actions. First, action 1, break it down. The next time you get a task, don't just do it. In your portfolio log, write it down and break it into 3 to 5 smaller subtasks. That's the start of a bottom-up estimate. Second, action 2, use the tool. Pick one of those small subtasks and apply the 3-point PERT estimate. Write down your optimistic, most likely, and pessimistic times. Then, show you're working for the PERT formula. Third, action 3, reflect with star. After you finish the task, compare your estimate to the actual time. Then write a simple star reflection. Situation, I had a task to configure a new server. Task, I needed to estimate it. Action, I used the PERT formula, 1 + 4 2 + 4, 6, and my estimate was 2.16 hours. Result, the task actually took 2.5 hours, so my estimate was 86% accurate. My manager was able to plan the work confidently. That's a perfect, concise story for your assessor. Now, listen closely. This is the most critical advice I can give you for your final assessment. K15 is also a core part of your final project report. This isn't optional, it's a specific requirement for a pass, and doing it well is key to a distinction. The EPA plan explicitly says you must appraise own performance by comparing the outcomes of initial planned resources, timescales, and costs against actual outcomes. Here is exactly how you do that. First, in the project planning section of your report, you must state your initial estimates. Show the plan you made for your project's time, cost, and resources. This is your planned baseline. Second, in your evaluation or conclusion chapter at the end of the report, you must return to this. You will create a simple plan versus actual table. I call this a variance analysis table. It should show planned time versus actual time, planned cost versus actual cost. And the most important part, you then appraise this table. You explain the why. Why did the project take 15 hours longer than planned? Why did you come in under budget? This reflection, this comparison of plan versus actual, is one of the single most professional things you can do. It is precisely what the assessors are looking for. Let's do a quick recap. Today, we have demystified the principles of estimation. We've learned that an estimate is a forecast, not a promise, and that its accuracy is always governed by the cone of uncertainty. We've learned that we start with a ballpark, top-down guess, but we build a real plan with a detailed bottom-up estimate. We've put two powerful techniques into our toolkit, the Three-Point PERT formula for creating a weighted, defensible forecast, and we've seen how Agile teams use relative estimation and story points to do the same thing, manage uncertainty and create a plan. Now, your mission. I want you to practice this. This week, pick just one action from slide 9. Take a real task. Break it down. Try the PERT formula. Write that star reflection. Turn this knowledge into a skill. In our next session, we'll dive into K16, the fundamental concepts of computer networking, the invisible infrastructure that connects every single solution we've been talking about today. Thank you for your excellent focus. You've learned the principles that build trust and make you a credible, professional practitioner. Well done.